Okay. There is another quiz based on loops, but I will wait with that a bit and just do the functions and methods slides first, and then we'll do the quiz. Functions and methods. In the processing book, they talk about like one of the motivations to have that in the language at all is something called just breaking down tasks, and it's not really the whole truth about it, but I guess it's a good starting point at least. Yeah. So there's this example of maybe we have like a draw function that does a lot of stuff. Maybe it just does this. It sets a black background, and then it's like a game that draws a spaceship and some enemies and like a game for that, and then it updates some movement of those. And the idea is that we can factor those out into separate functions. So that's the most simple way to use a function. So we make a function called draw spaceship, and this is just using it. So whatever code is in the draw spaceship function we don't see here, we just call it. And then of course we draw the enemies, maybe. And then there's some update that actually moves them around. Move spaceship and move enemies. Yeah. Let's just write what I said. We call some functions which do part of the work. So here we just use the functions to make the code more readable, you could say. Instead of defining the functions, we just take all the code of each function and just put here. So we'd have like a very long draw method, and it would do exactly the same. There's no functional difference. It's just a way to organize the code. So this is a function. This is a function. And this one. I mean, this is actually also a function, but this is a system-defined function. And these are all something we defined ourselves. Could you be quiet, please? Oh, could you close the door, please? Sorry. Be quiet, rest of the school. And the book lists these sort of possible benefits. These are some words that you see a lot in programming literature. Modularity, if I can spell it at all. Modularity and reusability. So I guess what we mostly use this for here is the modularity keyword, right? So modularity means that we split stuff into smaller modules, so we can easier look at one, and that's a smaller thing to have on the screen one at a time. Reusability is this is not about reusability, but this is actually another important reason to use functions, is because we can use a function to do several different things. So the same piece of code that does different things instead of copy-pasting the code. Yeah. So function functions. Something we call definition. Definition of a function. And we will just take this stuff from here. And maybe put a little box. So each of these needs to be defined. I mean, these are using the functions. Is not defining them. Defining them is actually declaring the code of the function. So we can do that over here. Do it like this. Draw. We take this draw spaceship function. Draw spaceship. And this is the definition of the function. In here there is the code. I'm not going to go into that, but just the yellow stuff, that is whatever is needed to draw the spaceship. We'll not go into that, but that's a bunch of code. The void word, that's actually a data type. So a function always returns some kind of value, except if you write void. Void is a data type that means don't return anything. So it's kind of a backward way of saying it, but you'll see that a lot in code. So whenever this keyword void is there, it means that the function doesn't return a value. It just performs some task. And let me just draw another, just to make it clear that this is the same. This is the draw spaceship function. There. So this is also to illustrate what happens when this stuff is executed. Remember that execution is from top to bottom, one statement at a time. So the computer does this, and then it does this, and this actually causes a branch to happen. That's another kind of branch. So the branch is actually jumping over here to this code here, and then executing from top to bottom here, until it gets to the end of the function. Now the function is done. Then what the computer does, it remembered where it came from, so it jumps back, and draw enemies does that. So you can also think of it as like an expansion. And lastly, those terms that we use here, the function is called. We say calling the function. Because that's that called. And over here, the function is defined. So we call that the function definition. Okay. The next topic is something called arguments functions. Arguments. That's what that is. Another word for that, kind of a fancy word, but I think it's actually a good term. Parameterization. This is where the reusability part comes in. This is how you make functions reusable. You parameterize them. So you add some parameters to a function to change the way it behaves. So when you call it, you can change the value of the parameters and you get a different result or a slightly different result from the same code. So first we have an example here of a function that does not have any parameters. Draw black circle. Very simple. Here we actually put the code in the example. This is processing code. Ellipse. This is a 20 radius circle in the center of 50 by 50. This is the definition of the function. It's very simple. And if we call it, we simply do it like this. That's where these two parentheses come in. It's to call a function with no parameters. But to make it more useful, we parameterize the function. We add a parameter, or as we call it, an argument to the function. So let's make the function a variable with respect to the radius of the circle. So this version of the function can only draw a circle which has the radius of 20. It's the only thing we can use it for. So if we want a different circle, we need to write a new function. But if we add a radius parameter, then we can use the same function for drawing different sizes of circles. They still have to be black, because that's sort of hard-coded in the function, but we can change the radius. I think it's actually diameter, this parameter. So not radius, but it's fill 0, ellipse 50 by 50, diameter, comma diameter, like this. Okay, so first of all, the diameter is called an argument to the function. It's a function argument, and we declare that by giving a data type. In this case, it's something called a float, which is a decimal number, not necessarily a whole number, and then a name, diameter. And then we can refer it just as if it was a local variable. So in here it looks exactly like a local variable, but it is actually something slightly different. It's a function argument. And the way that works is that when we call it, we can give an expression that evaluates to something, which is then put into this local variable. Draw a black circle 35, or anything really. Just put an arrow here to make it clear that it's this arrow is the parameterization of the function. So defining the function in these parentheses, that's why they're there, we put the arguments. In this case, it's only one argument. Remember that these are little expressions. We call another function a built-in function called ellipse, and these are little expressions. In this case, just the name of the variable, so it just it will evaluate to whatever value this variable has. And the value it has would be, of course, what we put here when we call the function. Okay, now a little more about this return value that we saw, or lack thereof with the void. Yeah, so I will write a function now that calculates the distance between 2 points. Call that distance, and we'll give it 4 arguments. And those are the coordinates of the 2 points that we want to calculate the distance between. Yeah, so this function has a return value, and that is a float return value. So that's what you do at this point. You specify the type of the return value for the function. Remember before we wrote void, and that's because we don't always want a return value, so we don't want a function to have a return value, we just want to do stuff. Then we use void, which is kind of a fake data type, you could say, or an empty. A data type without any data. But in this case we want data returned because actually this is what the function does. It doesn't do anything else. It has no what you call side effects. It doesn't draw anything or do anything. It just calculates this one value and returns it. And that's what happens in the last statement, this special return statement. What value to return? This one here. Maybe just put some. This and like this. So those are the new things with this function that has a return value. Now let's see how we can use a function like this. It's actually similar to one of the exercises. So again, we call the function by specifying some expressions that give values for the arguments. And then the whole function call is actually an expression because it returns a value. So in this case, it's an expression of the type float. So we get some float number returned here, and then we can use that in this Boolean expression to test if it's smaller than 100 and draw a circle if it is. Okay. Lastly, which is something we can use for the next topic, we can do a similar example to what we did with data types. Like an example with the Pong game. Just find that. Where is that? Oh, it's in here. So remember we took this game and then we looked at what is the data, what are the variables that we need to store the state of this game. Now I'd like to talk about what would be the functions. Like if we were to split up this whole game into smaller functions, what...
Speak louder.
Louder?
Speak louder.
Yeah, I'll try to speak louder. What are the functions? What could be the functions to break down this game into slightly smaller pieces? So, does anyone have a suggestion for some functions? Yeah?
An update function taking care of frame rate on load number.
Yes, an update function. I was wanting something a little more detailed than that. So an update function that updates the whole game could be broken down into...
Update function that updates the position of the ball.
Yeah.
One that updates the position of the players.
Yes. So we could say update position of ball. call it. And just put some arrows so we can see what is happening. That's of course related to the ball. And those are of course related to the bats. Any other ideas? Yeah?
You can have a function that draws the bat.
Yeah. Yeah.
I mean, the function that changes the direction of the ball when it's hit by the.
Yeah. I mean, that is of course maybe slightly implied in what you said, like update the position of the ball, but I had that as well. So we can maybe draw the sides here. Yeah.
Can you read a function for the score list?
Yeah. Call it count points, but it's just coming up with the name really. It's a lot of lines here now. Yeah.
Maybe a function for the speed of the ball.
A function for the speed of the ball. Like how it changes.
Yeah, and every time it's being hit by the bat, maybe it changes, the speed increases every time the ball is on the right side and decreases, I don't know, a couple of moves.
Yeah, I think that's maybe already in the update position of ball. That's pretty good. As I said, I'm going to use this when we talk about objects. So we're done with these. I'm going to just switch off the screen recorder.